Hello, Legacy Sabers, Marsh here. So today we're going to talk about the last two protocols that we need to make the internet work, HTTP and DNS. So our essential question today, what happens when I type an address into my web browser? So imagine if you had to keep track of everyone's IP addresses to send a message. It would be kind of annoying, right? You'd have to have a book that you'd have to write everybody in. Now remember, IP addresses also change based on where you are and what network you're connected to. So not only would someone have like a permanent IP address, you would literally have to change it no matter where that they are, and you would have to know where they are. So theoretically, it would be completely impossible to keep this list up to date. Thus, and if our internet continues to grow, as it is, and we have billions and billions of devices, we need to figure out a new way to be able to hold one another's IP addresses. Thus, DNS was born. So, go ahead and pull up your Unit 2 notes, and you're going to want to go to the section that's DNS Video Guide. So what we're going to do is we're going to watch the DNS video here so that we can learn a little bit more about DNS. Then we'll join you back here, or I'll join you back here. Make sure you fill out your video guide as you are watching this video.
Most users never see or care about internet addresses. A system called the Domain Name System, or DNS, associates names like www.example.com with the corresponding addresses. Your computer uses the DNS to look up domain names and get the associated IP address, which is used to connect your computer to the destination on the internet.
And it goes a little something like this.
Hey, hi there. I want to go to www.code.org.
Yeah, I don't know the IP address for that domain. Let me ask around. Hey, know how to get to code.org?
Yeah, I got it right here. It's 174.129.14.120.
Oh, okay, great, thanks. Yeah, I'm gonna write that down and save it for later in case I need it. Hey, here's that address you wanted.
Awesome, thank you.
So how do we design a system for billions of devices to find any one of billions of different websites? There is no way one DNS server can handle all the requests from all devices. The answer is that DNS servers are connected in a distributed hierarchy and are divided into zones, splitting up responsibility for the major domains, such as .org, .com, .net, etc. DNS was originally created to be an open and public communication protocol for government and educational institutions. Because of its openness, DNS is susceptible to cyber attacks. An example attack is DNS spoofing. That's when a hacker taps into a DNS server and changes it to match a domain name with the wrong IP address. This lets the attacker send people to an imposter website. If this happens to you, you are vulnerable for more problems because you are using that fake website as if it is real. The internet is huge and getting bigger every day, but the domain name system and internet protocol are designed to scale, no matter how much the internet grows.
Okay, you're back. So DNS, as I talked about, stands for Domain Name System. All the Domain Name System is basically he holds a roster for us of everyone's and every website's IP address. There are multiple DNSs because we can't just have one, right? If we had one DNS, then we would have overload of our information. So how does DNS solve the problem of translating domain names into example.com into IP addresses? Well, all they do is like I said, they hold onto a list, and when you ask them, hey, I'm trying to go to example.com, it says, you know what, I have an IP address for that, it's this. So then when the IP address changes, it is able to be changed in the domain name system. DNS helps the internet scale because we don't have to worry about holding on to IP addresses, right? If we need an IP address that we've never visited, maybe we never visited a website, the DNS is going to hold on to that. And also it can go to an upper level domain name server or domain name system, if it doesn't have that information. So it is allowing us to scale, to grow, to make it easier for us to see and get information. So we're going to go look at the final version of the Internet Simulator. This time, we're not going to cheat and we're not going to ask out loud for IP addresses. So I'm going to jump onto my internet here. Okay, so I have joined my my information here. Right here, I am on 2 different routers. You know what? I'm actually going to get myself on the same router. There we go. Now notice what is happening here. I cannot find the IP address of this person. It is a question mark on both sides. So what I need to be able to do is I need to talk to our DNS. Now my DNS is 2.15. So to get information, it tells me right here how to do it. To get information, I have to put get, capital G-E-T, and then the host name that I'm interested in. So I'm going to send a message here. Zoom out a little bit more. Okay, so I'm going to send an IP address or a message to my DNS 2.15, and I'm going to say capital G-E-T, and I want the IP address of Alicia 3. I'm going to run that. So now see what has happened. It's telling me Alicia 3 is on 2.12. Now over here on Alicia 3, I could ask DNS. So I got to go to 2.15 again. And I'm going to say get Alicia 1. I do need to know the information, kind of like how you need to know the website's name. You can't just be like, take me somewhere. So I have to ask it. So it tells me that I am in spot 2.3. So now if I send to IP address 2.3 and I'm going to say hello, I will get a 2 from 2.3. From my message 2.12, I will receive hello. So this idea that I need that domain name system to have all the IP addresses of connected computers. Now, if someone was on a different router, so for example, if I disconnect here and I go to router 6, I am on a different router, but here's the cool thing, is I can still ask my DNS to get me Alicia 3's information. Taking a minute here to find me. Oh. Oh, there it goes. Took forever. There we go. So I got Alicia 3 is at 6.7. So even though I'm not on the same router, my DNS still can go and look me up and go and find me. Now I'm guessing if I looked at my router log, I'm going to guess it took a while to find Alicia 6.7 just because I was on quite a bit of spread of my routers. So the ability for DNS to be able to, you as a person, as your computer, can go to DNS, say, hey, what's the IP address for this? And DNS is going to have that information stored in there for you. You don't have to control DNS to make it do that. It's just going to do that for you, which is quite nice and quite useful as we continue in our world. So DNS, as we said, it translates our IP addresses to our domain names, aka website names, and or website names to IP addresses, depending on which way you're looking at. Now we're going to discuss the last piece of our puzzle, HTTP. Now you've probably seen HTTP before. Usually it's in front of a URL, aka a website. HTTP is a protocol that defines how users of the internet request and receive data, like web pages, images, video, audio, and files from servers containing them. So HTTP is how we interact on the internet and how the website looks. So here's how this kind of works. We have this IP address. Let me get my laser pointer here. So we have a client, aka your computer, sends an HTTP request to a server website. That website sends the information that you need across with an HTTP response. Now, these, as it's sending back, it is using packets. It is using TCP, which, remember, he's the guy that error checks your packets to make sure they go back in order for you. And then you also have those IP addresses that are working in there. So let's dig a little bit closer here. So when I type in a URL of my browser, your computer needs to ask the server that is storing the data to return the content so your browser can display it. So that's going to look like an HTTP request. Here's what's inside of an HTTP request. You have the method that you want. There's two kinds of methods. There's a GET request and a POST request. GET is what it does. It gets. So it's getting me a picture. It's getting me a video. Post is when you're sending something to the server. So maybe you're pushing submit on a form. Maybe you're pushing login button. That is when you are sending something. The resource that you're trying to access would be the next thing. Then what kind of version of HTTP are they using, and any other additional info that's needed to be required to send that information. So that is what a general HTTP request looks like. It gets sent to the server looks at it and says, I'm supposed to send back the logo. So then it responds with some information. An HTTP response looks like this. We receive what kind of version of HTTP are we using, the status code. 200 stands for OK. You may have seen 404. That is not found. That's a status code for HTTP. I believe 400, I think, is forbidden. That's when you're not supposed to be able to look at that information. There are various HTTP responses. I really do enjoy looking at them on Wikipedia. There's one for I'm a Little Teapot, which is a really weird HTTP response. But different status codes that you have the ability to. Headers, basic information, and then the actual binary or actual data that you are actually requesting for the computer, the server, to send back to you. Okay, so let's go look at some actual HTTP requests. So here I have the Bismarck Public Schools website. What I have done is I've clicked right click, I've clicked inspect, and then I'm going to go to network. Now on your guys' computer, you guys don't have access to this because of it being locked apart. But if I refresh my Bismarck Public Schools website, what I'm going to get is all of the information that I need to get/post to receive the Bismarck Schools website. So what I have here, and I got to make sure I do my method as well. There we go. So what I have is my method. So I have get, because I'm getting the information. Status code, that would be that 200. It's okay. And then what kind of information am I getting? I have how long it took me to get that information. So for example, right here, I have a font that I received from somewhere. 304 not modified is one of my status codes. I'll see, do I have a post request? I do. Right here we have a post request, so I had to send some kind of data. Interestingly, it's called rum for my value there. Same thing with send. I had to send something to the server to receive that information. But I have a bunch of these gets. 204, there's no content there. So I have a lot of different information. As you're looking at this, like let's say I go to a youtube.com. You're going to get quite a bit of information on it. I have my watch history turned off on my account, but as you can see, I got some posts in here. And if you actually watch a video, what you'll see is this is going to get really fancy and keep popping things up because you are literally sending data constantly. And there are stuff that has been blocked, and that is probably because I have my stuff turned off for my watch history. But what you can see is the method in which we're getting it. You're going to get a lot of GET requests to get one single video or one single website. It's never just going to be one video or one GET request when you're looking at your HTTP requests. It's got to be a lot of them because we got a lot to look at. Okay, key takeaways. Some vocab that we need. Scalability. The ability for our system to change in size and scale to meet new demands. Our web internet needs to be scalable because every day there are new things that are being added to our internet that needs to be added. We have computers, cell phones, tablets, smart fridges, smart watches, smart toasters. Everything that is becoming and being wired into the internet needs to be able to be scalable, so we need more room to be able to hold on to stuff. The domain name system is a system that, like we said, is responsible for translating domain systems into example.com into IP addresses, so you can kind of go back and forth with that information. He's the reason why we don't have to keep track of all of everyone's IP addresses, kind of the superhero of the internet. World Wide Web, he is the system of linked pages, programs, and files. He is the guy that we browse with the internet. Remember, the internet is the network. The World Wide Web is all the stuff on that network. HTTP, protocol for computers to request and share data over the World Wide Web, or over the internet that makes up the World Wide Web. So as I said, the World Wide Web is different from the internet. World Wide Web is the files, and then the internet is the network you use. So the internet is the physical wires of it. The World Wide Web is the stuff that's on that we use to receive that information, or that we get from that network. DNS is just a very important thing that we need to help our internet scale and grow. Some IP or some AP style questions here. Best describes the relationship between HTTP and the World Wide Web. Well, we use HTTP to access the stuff on the World Wide Web, right? So the World Wide Web is a protocol used for sharing HTTP messages. No, right? The World Wide Web is a collection of pages and files that is shared between computers using HTTP. That sounds like a good answer, but it is a choose two, so I better choose two here. Computers will send information using either HTTP or the World Wide Web, but not both. Nope. HTTP and the World Wide Web both rely on other layers of the protocols for sending information. Yes, right? Because HTTP requires us to use DNS. It requires us to use the IP addresses. It requires us to use the TCP and UDP. So both of these rely on us to use other protocols to be able to send that information. So you got a little bit of homework. One more video for you to watch. This one is about HTTP and also its sister called HTML, which you may have heard. It's kind of a mock-up language to making a website. There are a video guide in your notes that I need you to fill out as you watch this video. Once you're done with it, then you have your information golden. So make sure you watch that HTTP and HTML video. When we get back, we're going to talk a little bit more about the layers of the internet. I will see you later, Sabers.